Good afternoon, audience, and welcome to today's class. Today, we will be looking at problem solving under the concept of trigonometry. In one of our previous class, we already had started looking at trigonometry as a concept in mathematics. We looked at some basic trigonometric functions as it concerns the cosine, the sine, and the tangents. We equally looked at the reciprocal of these quantities, which of course we're talking about what we call the cosec, what we call the cot, and what we call the what we call the secant. So today we equally looked at what we call the three basic Pythagoras identities. And today we want to begin to solve problems under trigonometry with you in a way and manner that at the end, surely you will have something to go home with. So what we have today is just solving problems. So we are going to call questions off from our question bank as usual, paste on a board, and then solve with you, calling up different trigonometric identities and functions that will be able to assist us come out of the problems victoriously. So let us begin with the first problem. Okay, the question I have here says, and I read, simplify. So the question says simplify. Question says simplify, simplify. That first question says sine theta, open a bracket. We have cosec theta minus sine theta, close the bracket, all over 1 minus sine theta. Look at the problem that is before us. That we should evaluate this or simplify this to be able to have a value that stands as the simplest value of this quantity. For us to solve this problem, first of all, we have to remind ourselves what is sine theta and what is cosec theta and the rest of them. So by a way of solution, I am going to start by saying solution. By saying solution, okay. I will now say recall that, recall that, recall that. Cosec theta, which is CSC of theta, is given as 1 all over sine theta. Anywhere you see in mathematics talking about cosec, written as CSC of theta, it is equal to the reciprocal of sine theta. This is one of the identity or the function we already proved in our last class. So if you really want to know how this quantity is equal to this quantity, we encourage you to recall our last class. So if you agree with me that this is this, let us go now to this problem. Then we now expand this problem by using this sign to multiply out what we have in the brackets. So what I have there becomes, what the question says is sine theta, open a bracket, CSC of theta minus sine of theta, close the bracket, all over 1 minus sine theta. That is the question before us. Then this sine theta coming in here, will now be able to have sine theta multiplying by CSC of theta, which is this, minus. This sine theta multiplying by sine theta will give us what we call sine square theta. So we have what we call sine square what? Theta. All over 1 minus sine theta. I want to quickly explain something here. That when we have something like sine squared theta written this way, it is same as writing sine theta all raised to power 2. So they mean the same thing. This and this mean the same thing. But to avoid issue of confusion, let me retain with the sine theta all raised to power 2. So what I have here, we already have told ourselves that sine theta is here and cos theta, that is CST of theta, is 1 over sine theta. That is cosec theta is 1 over sine theta. So in place of this CSC of theta, I am going to use 1 over sine theta. And what I have there becomes, here is my what? Sine theta, which is what is in the equation. Here is multiplication multiplied by. In place of this CSC theta, I am no longer going to use this, I'll use its equivalence, which is 1 over sine theta. So I have 1 all over sine theta. The sine here is what? Minus. I have what? Sine theta all raised to power 2 all over 1 minus sine theta. That's what I have. Then I have sine theta here, I have sine theta here, they can go. So this will cancel this. So what I have here, all standing alone, is what? Is 1. So I'll be able to have what? 1 minus. What I have here is what? Sine theta all squared. So I have what? Sine theta all squared. All over 1 minus sine theta. Okay? Of course, we know in mathematics that when we have a 1, it can be written as 1 raised to power 2 without necessarily changing anything in the system of the equation. So I can easily write this in I have here to be what? 1 raised to power 2 minus sine theta all raised to power 2 all over 1 minus sine theta. I can have something like this. At this point in time, of course, I know that this thing has become what we call difference of two squares. And when you have difference of two squares like this, let me show you what I mean. When you have difference of two squares like this, you have a raised to power 2 minus b raised to power 2. It is expressed as what? A minus b, open and close, open, a plus what? B. This is how to express difference of two squares. So I'm going to use this knowledge to express this. I am looking at this 1 raised to power 2 as if it were a raised to power 2, and looking at this sine theta raised to power 2 as if it were b raised to power 2. To enable me express this in this format. And then it becomes 1 minus sine theta, open and close, open again, 1 plus sine theta, close, all over 1 minus sine theta, which is what I have before. There is 1 minus sine theta in the numerator. There is 1 minus sine theta in the denominator. Both of them can go. And when they go, what we have is, here is 1 and here is what? Is 1. I am left with what? 1 plus sine theta as the answer. So they can make you to solve this in more by telling you, if theta is this, evaluate your final answer. So you'll be able now to come, if it is what, something like 30, sine 30, 1 over 2, it becomes 1 over 2 plus what? 1, becomes 1 over 2. So this is how to go about solving this kind of problem. So the only thing that is necessary to make you come out of this problem is to recall for yourself what cosec theta is. That cosec theta is 1 all over sine theta. And you remembering this, bringing it into here now makes this to cancel off. And you are now battling with 1 minus sine theta all squared. And remembering difference of two squares, now you square your 1 and they arrive at this answer. So you see that solving problems in quadratic, in trigonometric functions, with trigonometric functions, is actually very, very simple. It only requires our knowledge of recalling these trigonometric functions or identities. And the moment we recall them, we don't have a problem. Our previous class extracted everything about the trigonometric functions and identities. So let me clean this one, call up another question while we go through it equally together. So these are the much that is done under this one, expressing this or simplifying this to arrive at this. Okay, the question number 2 says, which of course is where we are going to call up so many trigonometric identity. Okay, they'll ask us to simplify or evaluate, simplify or evaluate sec square the theta minus 1 all over cos square the what theta. That's what they ask us to evaluate. Evaluation of these three is very, very simple, but it requires us to remember some basic trigonometric functions. By way of solution, I am going to write this way, that this is, by way of solution, I have that this sec squared theta can be written as sec theta all raised to power 2. It can be written that way, of course. And then 1 over cos squared theta can be written equally as 1 over cos theta all raised to power 2. So it can be written that way. So by a way of writing it that way, what I have here becomes that I have that sine or sec theta all raised to power 2 minus 1 all over cos what theta all raised to power what 2 all raised to power what 2. But by a way of a trigonometric identity, okay, we are told that sec theta is the same thing as 1 all over cos theta. That's what we are told in trigonometric identity. We now go ahead by saying, but that sec theta equals 1 all over cos theta. We know this. It's a basic trigonometric identity, or an inverse, a reciprocal of one of the basic trigonometric identity cos. So I will now come back here and then replace, instead of writing sec theta, I will write 1 over cos theta there. And then what I have there, 1 over cos theta, becomes what? 1 all over cos theta. Remember, it is raised to power into 2, so I have open and close raised to power 2. Here is my minus 1 all over cos, then theta all raised to power 2. Remember that we know that any day we have something like 1 over 2 all raised to power 2. This thing becomes 1 raised to power 2 all over 2 raised to power 2. Of course, this thing applies in mathematics. So calling up this application from here to this, to what I have before me now here, it becomes what? 1 raised to power 2 all over. Here becomes cos of theta all raised to power 2. The sign here is what? Minus. I come here. This is 1 all over cos theta all raised to power 2. Of course, we know in maths that 1 squared returns 1. So this thing becomes what? 1 all over cos theta all raised to power 2 minus 1 all over cos theta all raised to power 2. And of course, 1 all over cos theta raised to power 2 is the same as 1 all over cos theta raised to power 2. So you are saying a quantity that is the same minus a quantity that is exactly the same thing with it. Just like you saying 1 minus 1 or 2 minus 2. And the moment you say 1 minus 1, the answer is 0. If you say 2 minus 2, the answer is 0. So 1 over cos theta raised to power 2 minus 1 over cos theta raised to power 2 equally returns to 0. So the answer of this what is 0. When this is simplified, the answer comes back to what? To 0. Okay? So you see how solving this kind of problem could be very, very easy. What if they had asked us, simplify the following? Then option A is given as this, option B is given as this, option C is given as this, option D is given as 0, or something of that kind. You just simplify and the answer turns out to be what? To be 0. Okay? So we are equally going to clear the board and then call up another question which we are going to solve, at the end of which we believe that we have left something very valuable in you. So simplifying this, you remembering that this can be written as this. You equally remember that this sec theta is given as 1 over cos what theta. Then you now come over here. Now instead of writing sec theta, you put 1 over cos theta, which is this. Subtract it by what? By that. Then of course, squaring the numerator and squaring the denominator, we arrive at this minus what we have here, which is what I have here. And then the point I have here becomes the point I have here. And when they are subtracted, it returns to what? 0. So the answer to that is what is 0. Thank you for your audience. Our effort is to continue to change your mindset about the understanding that people have about mathematics and statistics. We approach these two concepts, yes, in a way that encourages students to have love for the subject matters, mathematics and statistics. Thank you very much. Let me clean and then call up our notes. Okay, look at the question they ask us to solve. Let's see how we are going to go about it. That question says, and I write, that we should simplify sec square root x plus CSC square root x. Open and close, open again. Tan what? Square root x plus cot square root x, bracket closes. That we should simplify that quantity. We are going to try as much as possible to make you see certain trigonometric identities that we have here. We already have told ourselves what is sec. We already have told ourselves what is CS. But we have not really told ourselves what we mean by this cot. Okay? Cot is actually what we call 1 over tan theta. That's what we call cot, 1 over tan theta. But what we are going to do here is to come here by a way of reminding ourselves. We tell ourselves that sec theta here, we have 3 basic Pythagoras theorems or identities, Pythagoras identities. And those identities are, number one, that sine square root theta plus cos square root theta equals what? 1. That is the first identity that we have. That should not be forgotten. Our last class proved it. That this plus this is equals to what? 1. The second identity says, number 2, that 1 plus cot square root theta equals what? CSC of theta. This is the second identity, also proven in our first class. Then the third identity, which is number 3, says that my tan square root theta plus 1 equals sec square root theta. Our last class equally showed this. With this in mind, anybody can evaluate this quantity. So what are we now going to do in this quantity? The sign here is minus, please. The sign here is minus, please. That's the sign here. The sign here is minus. Okay? So we are told to evaluate that. So let me call it up here, and then we evaluate it together. So what we have here becomes, we have sec square the what x plus CSC square the what x minus open a bracket. We have tan square the x plus cot square the what x close the bracket. So we come here. So when we come here, what we are going to do is this. We have already known that sec square the x is given as tan theta tan square the x plus 1. So in place of this sec square the x, which is what I have here, I can write this quantity. So I'm going to write this quantity in place of this place. So what I have that place becomes, in place of this one, I am going to write this. So what I have is what? Tan square the what? Theta plus 1. This thing is in place of this sec square theta, which is what I have here. The sign here is what? Plus. It's a plus. I know that CS square the what? Theta, which is what I have here. Okay? If I come here, CS square the theta here, I know that CS square theta is given as this quantity. So instead of writing the CS square the theta, I am going to write 1 plus what? Cot square the what? Theta. So I'll come here in place of this. I have what? 1 plus cot square the what? Theta. What I have is here sec squared theta. Look at it. Look at what I used to replace it. What I have here CS squared what? X. Sorry, X, not theta, please. X. What I used to replace is what? Is 1 plus C, 1 plus cot squared what? X. Because the question they ask us is in form of what is X. So let me keep to X, please. The question they ask us is in the form of what? X. So let me keep to X. Even though when I was writing the identity, I wrote them in terms of what? In terms of theta. So, but then the question is coming in terms of what? In terms of X. So you should be careful with that. I'm sorry about that mix-up there. Okay. So, which means I will now say minus. This minus coming in there here, we'll have tan square the what? X. Minus tan plus minus. Coming in here, I have cot square the what? X. If you look at this thing, I have tan squared x here, I have minus tan squared x here. So this and this can go. I have cot squared x here, I have minus cot squared x here. So this and this can go. So what do I have here? 1 is left here, 1 is left here. So 1 plus 1 is equal to what? 2. So the value becomes what? 2. What if they had asked us to simplify this and write our answer? And begin give us values like 2, 3, 4, that and that. The answer returns to be what? To be 2. Please, situation whereby you are still having challenges on how to go about problems on trigonometric ratios and identities, please visit our previous class before listening to completely the class of this video. In our subsequent class, we are going to come up with a lot of problems to solve on trigonometric ratios or on trigonometry in mathematics. So stay calm and wait as we try our best to bring mathematics to you in a very simplified format. See you in our next class. This class might be tagged on YouTube as the problem solving on trigonometric ratio 1. Thank you very much.